myself Munilan,
myself Aravindan,
myself Sumit Kumar, take immense pleasure to introduce and explain you our project, that is Conic Section in Science, which is guided by Mr. T.MURALI, PGT Physics of Kendra Vidyalaya, DGQA.
Now a question arises, what are conic sections? Conic sections are the curves obtained by intersecting a right circular cone with different planes.
Let's see. If we cut it parallel to the base, we will get a circle, and if we cut it obliquely, we will get an ellipse, and if we cut starting from one point and to the base, we will get parabola, and if we cut it perpendicular to the base, we will get hyperbola. So we got 4 sections of a cone, and these are nothing but the conic sections. So we would like to show this with the help of a watermelon. So this is a right circular cone.
When we cut it with a plane parallel to the base, that is, we should cut it keeping the lines parallel to the base, we get a circle. Let us see how we get it. A circle is mathematically defined as the set of all points in the plane which are equidistant from a fixed point in the plane. Aha, here it is. We have got a beautiful circle. Now to get an ellipse, we have to cut it obliquely, that is making some angle with the base. Normally cutting watermelon and eating is a day-to-day life process, and we also enjoy doing it as it is very yummy. But we have seen this in a different way so that we can teach maths through this. An ellipse is mathematically defined as the set of all points in the plane, the sum of whose distances from two fixed points in the plane are constant. Actually, first we thought to buy this watermelon only for eating purpose, but we also knew that it has great mathematical ability, and we can use to express this.
Wow, how beautiful! We got an ellipse.
Next, our target is to obtain a parabola. For this, we have to cut it with a plane starting from one side and end it with a base. Practicing for this project, we have become experts in cutting vegetables, and this would help us in bachelorhood life.
Here we got a parabola.
To get a hyperbola, two cones have to be named together, but this is not practically possible. So let us take the back part which we have cut already, and now we will get a hyperbola.
To get a hyperbola, we have to slice it with a plane perpendicular to the base.
A hyperbola is mathematically defined as the sum of set of all points in a plane in which the difference of whose distances from two fixed points in the plane are a constant.
Here we got the hyperbola. The first child of mother cone, that is the circle, can be used to explain J.J. Thomson's model of atoms, which states that the positive charges are spread all over the atom and the negative particles are embedded over it.
We can see this through this red pulp. We can assume this red pulp to be the positive charge and the seeds of watermelon to be the electrons.
So we used to explain the Bohr's model of atom.
In Bohr's model of an atom, the whole positive charge of an atom is concentrated in the small space at the center called the nucleus, which is seen red inside the CD. And the negative charge electrons revolve around the nucleus in circular orbits. The first orbit can hold maximum up to 2 electrons, the second maximum up to 8, and the third also 8. I have got a beautiful atomic model. Let us see which is this element. 2 plus 8 plus 1, it's sodium. So we have obtained the electronic
Let's
configuration.
move to the second child of mother cone, which is an ellipse. This can be used to explain the planetary motion, in which all the planets revolve around the sun, keeping the sun at one of its foci.
Here goes Mercury, then Venus, then comes Earth, then the red planet Mars, Jupiter, Saturn, Uranus, and finally Neptune.
Wow, how beautiful. So this can be seen in the picture given in the chart. Now let's go to the third child of mother cone, that is the parabola. This can be used to explain the projectile and the trajectories.
We all know about projectile, that is an object thrown with initial velocity and then move under the action of gravity, and the path followed by a projectile is trajectory, which is a parabolic path. Now let us consider this to be the path of the projectile. Here an object is thrown from this point, making angle theta with the base with velocity u. And this velocity component can be resolved into two components, which are u cos theta and u sin theta, where u cos theta acts along the horizontal x-axis and u sin theta acts along y-axis. In this way, at any point x, we can measure the components of velocity, that is u sin theta and u cos theta.
So that's about fourth child of mother cone, that is hyperbola.
Normally, hyperbola are not used in science maths, but still hyperbolic mirrors are used in optics to a great extent. If you see the Cassigan deflecting telescopes, hyperbolic mirrors are used, and these mirrors have the property of deflecting light from that falls into the focus into the other focus.
This can be seen in the picture given in the chart.
The hyperbolic mirror has a property, that is, it has two foci, focus 1 and focus 2. Its property is it directs a light ray falling towards one focus and deflects it into the other focus.
This can be done in the school. The teacher may ask the students to bring the fruits in conical shapes, and I'm sure the students will enjoy doing how maths is modeling the science. And now let's move on to our initial target, that is to taste the watermelon. Wow, yummy.
Really
So tasty.
Hope you enjoyed our presentation. Thank you.